Moons. In particular, we're going to look at the moons of Jupiter and Saturn, and not even all the moons of them, just some of the larger moons, because, as you can see here, Jupiter has 66 moons, roughly. We keep finding moons, and then other moons we thought we saw, we lose sight of, but it's roughly 66 moons that we know about. We're going to talk about the 4 largest, and these are the 4 that Galileo saw through his telescope. So these are called the Galilean satellites. Satellite is another word for moon, so you will see those two words interchanged quite a bit. So these are the ones that are bright enough that even through a small telescope or even good-sized binoculars, you can see these moons around Jupiter. We're going to start with Callisto. Callisto is the farthest from Jupiter of these 4, and that's important because we're going to find that Jupiter has an influence on things that are happening on its moons. And so being farther away from Jupiter, Callisto is not going to be influenced nearly as much. As you can see, composition is this mixture of ice and rock. And when we talked about the general characteristics of the solar system, we saw that ice and rock is very common for the outer solar system, and it is very common with the moons as well. One of the things that's very unusual about Callisto is that it is not differentiated. That means it does not have layers in its interior. And for something as large as Callisto, and it's comparable in size to our moon, you would expect layers in the interior. And so the thought is that it must have had a very slow cold formation. It didn't generate enough heat to melt the materials, and so the interior of Callisto is just this even mixture of the ice and rock, rather than the heavy, denser rock sinking to the center and the ice being on the surface. You can see in the picture that Callisto is very cratered. As we look at all of these spots on here, those are all craters. They're white because of the ice content on Callisto. So all of these white spots that you see here are craters, and it's just like, hammering ice, and you get these stress features that are brighter and whiter. That's what you're seeing in these white spots all over Callisto. The fact that it's not differentiated, that it is heavily cratered, we do think of Callisto as a dead world. It is not geologically active at all. Nothing has happened to alter its surface over time. The next moon in to Jupiter is Ganymede, and this is the largest moon, not just of Jupiter, but of the entire solar system. In fact, it is bigger than the planet Mercury. So this is a very, very large object, and it's a moon because it orbits Jupiter. If it were orbiting the Sun, we would consider it a planet. Composition, we still see that half rock, half ice mixture. But now it is separated into layers. Ganymede does have a core that is composed of rock and metal. and then the crust and mantle are ice. The surface of Ganymede, when we look at it, is a young surface. We see very few craters. Remember that crater counts is our best way of estimating the age of a surface when we can't get samples. And though, yes, there are craters here, all these little white spots are craters, it is not the same kind of crater density that we see on Callisto. And one reason why the surface might be so young is that there might be liquid water under the surface. Now, Ganymede is very far from the sun. Temperatures would be expected to be very cold, so the question is, how do you get liquid water on such a cold object? And the answer is Jupiter. When moons orbit Jupiter, so here's Jupiter, here's our moon. As it goes around, it's not a perfectly circular orbit, so there's going to be times when it's closer and times when it's farther away. And Jupiter's gravity is tremendous. It's a huge planet, so when it pulls on the moon gravitationally, the pull on the near side of the moon is going to be a little bit stronger than the pull on the far side of the moon. And that's what generates tides. It's the same way that our moon generates tides on Earth by pulling on the surface of water stronger than it pulls on the Earth below. And the effect is that it changes the shape of the moon. It makes it more elongated. Now that's very exaggerated. And when the moon is closer to Jupiter, that effect is going to be even stronger. So every orbit, which these moons orbit in less than a day, every orbit, it's essentially going back and forth between being round and being elongated. And that creates friction in the interior. And that friction is what's going to ultimately melt the ice into water. So the fact that Jupiter is so big, and the fact that Jupiter can alter the shape of its moons so dramatically, is the reason why we can find water so far from the sun. Europa is going to have a similar tail. Now, I mentioned earlier that distance from Jupiter plays a role in a variety of things concerning the moons, and one of the things that it plays a role in is composition. Where Callisto and Ganymede were this even mixture of ice and rock, Europa is mostly rock. With a thin ice crust. And that has to do with the conditions near Jupiter at the time of formation. Jupiter, when it was forming, would have been quite warm. And so just as our hot forming sun favored materials that would withstand those high temperatures closer to the sun, which is why you have terrestrial planets made of rock and metal. The same sort of thing was happening around Jupiter as it and the moons formed. Conditions closest to Jupiter would have been the hottest and would have been most conducive to materials that would withstand that heat. So Europa, certainly the rock is going to have withstood the most, but it was cool enough to allow it to have a little bit of ice. Like Ganymede, Europa is also thought to have liquid water under the crust. And this is probably why we really see almost no craters. Because anything that impacts Europa is going to allow that water to seep to the surface. So you see, this looks slightly crater-like. That looks slightly crater-like. Those are the only two features I see in this image that look like a crater to me. All of these lines, well, again, you've got tidal forces altering the shape. So that's going to crack the ice. But then it fills back in with water, very much like what happens in the Arctic here on Earth. So again, we are looking at tidal forces from Jupiter that are going to melt the ice into water. Europa has a tremendous amount of water. There is actually more liquid water on Europa than there is on Earth. And that's a pretty dramatic finding. Of all the places in the solar system, Europa is one of the prime candidates for life because of the amount of water found there. The closest of our Galilean satellites to Jupiter is Io. So that is an I, that's capital I there. And as you see, it is composed mostly of rock. So we see this trend with the moons of Jupiter that you have a higher and higher rock content the closer you get to Jupiter. There's probably a metallic crust, core rather, as well. Io is a very odd-looking moon, and what's causing this odd appearance is that it is volcanically active. It is actually one of the most volcanically active, or I should say the most volcanically active object in our solar system. Volcanoes erupt almost daily on Io. So all these round features that you see here, those aren't craters. Those are volcanoes. And so it is erupting at a really highly regular rate. A lot of the material that you see on the surface here, the white that you're seeing here, are sulfur deposits. The reason why Io is volcanically active, we're back to tidal forces from Jupiter. But now, it's not melting ice into water, but melting rock into magma. So most of the interior of Io is this huge molten mantle, and the pressures that you get from that is what causes these eruptions, the volcanoes. So those were the 4 largest moons of Jupiter. We're going to look at 3 moons of Saturn out of roughly 62. Again, the numbers vary depending on whether we can confirm one is there or not, but it's 60-some moons going around Saturn. The largest of Saturn's moons is Titan. It is the 2nd largest moon in the solar system, just slightly smaller than Ganymede. And composition, we're back to the half ice, half rock theme. What makes Titan so unusual is that it has an atmosphere. It has an atmosphere composed of nitrogen. And the picture we see here, this was taken by the Cassini spacecraft using a very special filter to actually look through the atmosphere. But this green layer here is the atmosphere. And under normal conditions, without the special filter, you actually cannot see the surface of Titan. It is a very dense shroud of clouds that cover it. The dark features that you see in these images, those are not some strange rock that you're looking at. That is a methane lake. That's another of the bizarre things that was discovered on Titan. Titan is the moon that the Huygens probe landed on. So the probe went through the atmosphere and it actually landed like right next to one of these lakes. We have also, from the Cassini mission, found evidence for water underground. So again, like Ganymede, like Callisto, not Callisto, like Europa, like Io, we're looking at tidal forces, in this case tidal forces from Saturn are going to be the source of the liquid water under the surface. The last 2 moons are kind of thrown in for fun because they're just unique. For Saturn, Mimas here is considered a dead world. It's a relatively small moon, kind of at the borderline of being large enough to give it a nice round shape. We're looking at the ice and rock mixture again, but what makes Mimas interesting is this crater. This is a huge, huge crater. Whatever impacted Mimas to create that crater was just a little too small to break the moon apart. If it had been just a little bit bigger, Mimas would not exist. The other thing that's fun about that crater is that it makes Mimas look like the Death Star in the Star Wars movies. And the images, the first images of Mimas, came back very shortly after the first Star Wars movie came out. So a lot of people had fun with the Death Star analogy. And the last moon we're going to talk about is Enceladus. This is also a moon of Saturn. And Enceladus has geysers. That's what we're seeing down here. That erupt. Again, tidal forces from Saturn are our source of what's going on here. And it seems to be highly concentrated at that south pole. So one of the things people are hoping to learn from Cassini measurements is why are the geysers mostly at the south pole and not found elsewhere. But very pretty looking. It almost looks like it has jetpacks or something. But a very interesting moon. And there are many others that are also very interesting, but for the interest of time, these are the ones that we're going to focus on.